Okay, so we are going to extend our discussion of quadratic functions today and look more in the graphs. And then that's what we're going to move towards. We're going to switch to chapter 6 after this and really look at how you can change the equation into a graph, how you can use the equation to interpret a graph, and things like you can see here, we're going to do maximum and minimum values and what that means. And then the last lesson of this chapter is the section is going to be about word problems. So then, how does it really apply? Because there are a lot of applications of quadratic functions. And again, factoring and all that kind of stuff with quadratic functions is going to be a big part of grade 11. So there is a lot more extension you can do to this as well. And also, like I said, in physics and chemistry, science, as well, okay? And we're going to talk about profit and how it relates to quadratic equations. So even those of you that are into business may need to take 11U and 12U in calculus because there is quite a bit of math often in business as well. Okay, so when you have a quadratic equation or relation, then we have an important point called the vertex. So the vertex again is either the bottommost point or the topmost point here. It's where the parabola has symmetry. So this parabola here has symmetry around the vertex. This parabola here also has symmetry on either side of the vertex. So it's an important point, okay? And we're going to use the term, optimal value, or, which is really just the most extreme point. So again, when we talk about maximizing area, then the vertex is going to help us with that. We're going to talk about maximizing profits, then the vertex will help us with that kind of thing. Okay, so if the parabola opens up, then the vertex represents, so that's what this one here up, the vertex represents the minimum point. All the other points beside the vertex are greater, or it's increasing if you want to add the little arrows there on the end. And the y coordinate of the vertex is going to represent the minimum value. Whereas if the parabola opens down, so this is a down, then the vertex represents the maximum point of the function and the maximum value. So what you're going to see when we do the word problem lesson, that many of the the quadratic equations we have are going to have a negative a value, right? That makes the parabola open down. So you'll notice that will be one of the characteristics. So one of the things we're going to do as we move on is we're going to use the vertex. So here, this vertex is at a value of, it's hard to see, but -1 and 1, 2, 3, 4, -1, -4. And usually what we do is the x value is like what you're measuring, right? How many sides are in the fence you're trying to maximize? How many coats are you trying to sell to maximize your profit or whatever? And then the y value is the independent variable, right? So now that can be changed based on how much money you're going to make or whatever. So we are going to, if you want to highlight that too, we're going to mostly use the y coordinate. Okay, so then the minimum value here in the down parabola. Oh, I forgot to write the vertex, sorry. We'll do this one first. The maximum, sorry, I just got those backwards. There we go. The minimum value is -4. And so here, this vertex is 2, 1, 2, and then 1, 2, 3, 4, 2, 4. Yeah, this is x, that's 0, 2, 4. So then the maximum value is 4. Okay, so we only use the y coordinate of the vertex. And you'll see that when we do the word problems again, or when we talk about the optimal values in the 6.3 and 6.4. Okay? So we have this two ways that we can talk about quadratic systems. Sorry. So here we have a function where it just says y equals. It doesn't really tell you what that y value is yet. So we have a quadratic function. It gives out a single number for every input number. So we can input an x and solve for a y. And it always has two variables, x and y, similar to most of the equations you've dealt with, even in grade 9. And so when you have a graph of a quadratic function, one of the next things we're going to talk about is the x-intercepts. And we did that, oops, sorry. We did that, sorry, I don't know why it keeps doing that. We did that in the factoring section. We called them roots or zeros, right? So when you have a function, then we talk about the zeros of that function, and the zeros are where it crosses the x-axis. So when x is 0, what is y? And so we did when y is 0, what's x? And we did equations with time, right? So when height is 0, what was, holy cow. When the height was 0, when did it hit the ground, right? So the ground would have been the x-axis. Okay, and then over here, when you have a quadratic equation, and this time now it's set to 0, so the questions in the last section would have said solve or find the solution, solve it. So then we have the y value is 0, so all you're solving for is x, and we call the numbers the roots. And you don't necessarily need a parabola or a graph. You're looking for the numbers that satisfy the equation and that give y equals 0. Okay, so it's really sort of semantics, but we're going to do both of these. We're going to talk about what are the x-intercepts and the zeros of the function, and we're going to talk about what the roots are. And we've already done that with the quadratic formula and things like that. The numbers that make the x values or the roots that make the equation equal to 0. Okay, so in this, we're going to focus on the zeros. So the zeros are the x-intercepts. I can't spell, sorry. Are the zeros of the function, and so we're looking for the x values when y equals 0, or where does it cross the x-axis. And the x-intercepts of the function, we call those the roots of the equation. So if you have, there are three cases similar to what we saw last section, right? We did the discriminant, how many roots were there, or zeros. Were there two solutions, one solution, or no solutions? So we have, if we have two, that means the parabola intersects at 2 points. So this is the x-axis, so these are the 2 points here. You can have a parabola that only intersects once, and you can have a parabola that doesn't intersect at all. So here's the x-axis. You can see that it's shifted up and does not cross the x-axis. So these, the no zero one, again, once we get into the real cases of this, usually you'll see like it's going to be a negative out front. The parabola will open down. And again, when we had no zeros in the last section, that was because the discriminant was negative and it didn't, so you can't take a square root of that number. So that's not really a real, like on paper and pencil, whatever, or a paper and pencil task, but that's not a real scenario. Okay, so I had to try to squish these graphs in here, but the red one is this one here, and the blue one is this one down here, okay? And actually, I'll use red and blue. How about that? And so right now, in order to figure out some of the information listed on the left here, you would have to be given the parabola as well as the equation. The next section we're going to will be looking at taking this standard form equation and factoring it and changing it so that we can get information out of it. Okay, so that's what we're moving towards. Okay, so the coordinates of the vertex. So again, I had to squish it. I'm really sorry. This vertex is down here. So it's at x equals 6 and y equals -4. The equation of the axis of symmetry. So you want to look where the parabola is symmetrical, and you always you use the x value of the vertex. If you want to remind yourself of that. The step pattern. So starting at the vertex, can you go over one, up one, over one, up? Sorry about that. Let me just change that there. Over one, up, 1, 2, 3. This is obviously open up. So this step pattern, you look for the value out front here, look for the A value, which is in this case 1. So then it's just the basic step pattern. It doesn't really matter how far you want to go. And the y-intercept. So this is where you're looking where it crosses the y-axis. So when x equals 0. So you can even do this. If you plug in x equals 0, then you're going to actually get that this term is 0, this term is 0, and you're going to be left with 32. Or you can look here, and where it crosses the y-axis is 32. So I'm just going to write that down here, just in case. is the C value, okay? So, but you could do the same thing like you would have done in grade 9, plug in when x equals 0 and solve for the y-intercept, and you would have gotten that number at the end of the y equals mx plus b equation, right? So once you plug in x equals 0, then anything multiplied by x is going to be 0. So then you're left with the number that doesn't have an x value, basically. So, but again, if you're given the parabola like you are here, then you can just look at the graph if you can see it. The 0, so we're looking for where it crosses the x-axis. So it crosses at 4 and 8. And for now, you definitely have to use the parabola to do this. The next section we're going to do is called factored form. So we're going to factor the standard form equation and find what the x values are. It is a minimum because it opens up. And the minimum value, remember you want to use the optimal value or the y value of the vertex, which is -4. And so this last point here, we haven't really talked about this before. So you're looking for where is the y-intercept reflected. So you want to look for where it's symmetrical. So if the y-intercept we said was 32, then you're looking for the point that is also y equals 32. What's that x value? So here's the 32. So you look on the other side of the parabola, and there's the other point, okay? So then that's at 1232. So again, you would need the parabola for that. Okay? And then, so we have the coordinates of the vertex in this blue curve. So now we have 4 and +8. And I had to use the graph to find that, the parabola. So again, use the x value, which is 4. Now we have a 2 out front here, so the step pattern is -2, -6, -10. Remember, you're going to multiply by the a value of the basic step pattern. It obviously is opening down. You can see that in the parabola, but you can also see it in the -2. The negative means it opens down. So now the y-intercept is -24. I looked at the c value here, but you can also check out here where it crosses the y-axis. And the zeros are where it crosses the x-axis at 2 and 6. It has a maximum value. And then because I kind of had to squish because it prints weird, so this one, the maximum value for the blue graph is 8. Remember, you want to... Sorry, this should be... Yeah, sorry, you want to use the y value of the vertex, which is 4, 8. So you're going to use the 8. And then when you're looking for the symmetrical point, you're trying to find where it's symmetrical. So the y value will be -24. And you're looking for where does that, what's the x value for that? So it's 8 and -24. So this one for sure, like this last part here, you definitely need the parabola. Okay, so there are some textbook questions there. I'm also going to post the in-class assignment from last semester with solutions. So if you want to take a look at that and try that as well, the students would have been able to use their notes. So if you want to try it with your notes and then check your answers for yourself, you can do that. We still have a little bit more to this section before we have our final assignment. Okay, thank you.